Section 2.5 is called Word Problems and Equations. We're going to see how some word problems can be solved. Some specific kinds of word problems are going to be solved by writing equations and then solving those equations. But it looks like first we're going to do some quick, review problems. So it's like taking one step back before taking a few steps forward kind of thing. We did an example like this last class, didn't we? Where you just want to get x by itself. So what do we do first? I guess maybe I'll take this opportunity to kind of give a comprehensive review, as in, like, if there were parentheses, you'd look to clear those first. That'd be like the first thing you'd want to do, is clear any parentheses by distributing. There are no parentheses here. The next sort of priority is, are there any like terms that are already on the left side together or already on the right side together, and you would just combine those together. That doesn't apply here. So I guess for now the next thing we want to do is just start to get this 1x, okay, this x, okay, by itself. So as far as being on the left side, this x is not by itself. There's this -5 right here crowding it, and there's this +6 over there with it crowding it. So which one do we get rid of first? Because it matters, like I pointed out last class. So which one do we get rid of first? We get rid of this first. And so we would do that by doing the opposite of adding 6. We would subtract 6. And so the left side would now just be -5x. And the right side, what is -34 minus 6? That should be -40, I do declare. And is x by itself yet all the way, USA? No. This says a -5 times x, so how do we undo that? By division. So we divide both sides by -5, and that will leave x as the sole survivor on the left side. I apologize.
Don Howe, please call 1501. Don Howe, 1501.
I'm actually surprised. It's hard for you to know this, but out of all my videos, this is the first time that's ever happened, where an announcement happened in the middle of recording. So anyway, whatever. I will keep going. As I was saying, that leaves x as the sole surviving thing left on the left side. And the right side, what's -40 divided by -5? +8. And as always, just like last class, once you get x by itself, you're done. And the solution is x equals 8. Which means 8 is the number that if you were to plug it in for x, and it would be -5 times 8 plus 6, it would actually equal -34, making the whole statement true. That's what it means. That's what it means to be a solution. It's the number that could, or numbers, but it's the number that you could replace the variable with to make the statement actually true, So it's like -3 times what? -2 would actually equal 10. Well, yeah. And -3x, 10 is 12. Then we would divide both sides by -3 to get x by itself. And 12 divided by -3 is -4. Another one. Ooh, remember, we want to get rid of, we got to deal with this 7 or -7. We got to deal with this 20. Which one do we deal with first? 20. This separate term of, ready? Wait for it. +20. This is a +20. We subtract to get it out of there, okay? I know there's a minus sign right here, but that goes with the 7x. This is a +20. 20, and we have to subtract 20 from both sides to get rid of it. Okay, so we have negative 7x left over, and then the right side, negative 1 minus 20, is negative 21. We're getting this a lot, aren't we? 21 and 7. But this is going to end up being negative 21 divided by negative 7. X is all by itself, and 3. Okay. All right. So, okay, now the new stuff, I guess. The word problems. Well, you should always make sure you read carefully, because reading comprehension skills and just, and you taking the time and the focus, the energy, to make sure you comprehend the reading, that is clutch, okay? You can't plan out a mathematical strategy, like you can't translate what's being said here into math unless sometimes you have to read it more than once. That goes for me too. Sometimes I have to read something more than once in order to wrap my brain around it and come up with, how it translates into math, and in this case, like an equation. So I'm just going to read this out loud, if you don't mind. There were 19 bales of hay in the barn. Okay, 19 bales of hay in the barn. Tim stacked more bales in the barn today. So there were 19, and then Tim stacked more today. There are now 40 bales of hay in the barn. How many bales did he store in the barn? Did he store? You mean today? I don't know if I like the wording of this. But it's not so bad. So how many bales of hay did he store in the barn? So if we started with 19, if there were 19 already, and then he stacked more and ended up with 40, how many did Tim stack? So I don't know. Maybe just to improve this even just slightly, how many bales of hay, that might just make it clear what it wants. How many bales did he stack in the barn today? So what do we do in order to figure this out? If there was not, see, this is just, it's one of those things where it's tough for me to give a consistent, advice. You just kind of have to go problem by problem. And so what we do here is end up just doing 40 minus 19. And 40 minus 19 is 21. Because if there was already 19 and there ended up being 40, you could do 40 minus 19. Or actually, you know what? Let's, I just realized that maybe I should do it in a certain way like this, What is the unknown? Because if we're going to write an equation, so that's what I think we should actually do, even though this was super simple. Let's make it harder than it has to be, and let's actually write an equation that involves a variable. So here's what I need you to understand when you're in this kind of situation. Your variable is pretty much always going to be what you don't know, which is what they want you to find out. So what they want you to find out is how many bales did he store today. So we're going to call that B. So B will be like the number of bales stored. And if we wrote an equation with an equal sign and everything, with an equal sign, with the 40 with the 19, with the b variable, how could you write a full equation that involves all these pieces, including the fact that this b value, which we got to pretend that we don't know what it is, but what would be the equation? It would be this. It would be something like, well, if we had 19 to begin with, and then we added b to it, it would equal what? You know, the 19 that we already had, plus the number that Tim put in there today, and the total was going to be 40. So here's the equation you could actually write out using a variable of b or n or x, whatever you want. And then we would now solve for b by subtracting 19 from both sides to leave b all by itself. And so, you know, we could do it kind of like that way. Next, I think we got two more. Oceanside Bike Rental Shop charges $10 plus $6 an hour for renting a bike. Jessica paid $28 to rent a bike. How many hours did she pay to have the bike checked out? So so the deal is $10 plus $6 an hour for renting. And Jessica ended up paying $28 at the end of the day, like in full. And the question is, how many hours would that have made Jessica renting it for? Now, I know you guys are probably smart enough to work this backwards in your, even like in your head probably, to figure out this very simple question of how many hours did Jessica have this bike if she ended up paying $28 total. But we're gonna practice our equation writing skills and our variable assigning skills. And so what is unknown? The variable is what is unknown. And as always, like as usual, what's unknown is what they're asking you to find out, which is the how many hours. So let's say H is number of hours for Jessica. Okay, so here we go. The equation that you could write pretty much goes like this. It'd be $10 plus $6 times, see if it's $6 an hour, $6 for every hour, you would multiply 6 to whatever the hours was, and then just tack on 10. So if it was like 20 hours, it'd be 6 times 20. If it was 2 hours, it'd be 6 times 2. Well, we don't know, it's H, but we're still going to do 6 times H, because H for us is the unknown number of hours. And so we do 6 times whatever, and then we also add 10, and that's going to equal the total cost, which for Jessica is 28. And so there's our equation that involves this unknown number of hours that we can now find out by just getting H by itself. $28 minus 10 is 18, and then we got to divide both sides by 6. And so H equals 3 hours. So Jessica must have had that bike for 3 hours. Last example. This is kind of a special one. The sum of 3 consecutive odd numbers is 99. What is the smallest of the 3 numbers? We could also be a little more specific with numbers and probably say integers or maybe even like whole numbers, but whatever numbers. I don't want to muddy the water here. So it's like just whatever. Never mind. The bigger question is, what does consecutive mean? Consecutive odd at that. Consecutive odd. So what does the word consecutive mean in everyday English language? And what do you think this kind of means? Consecutive odd numbers. Well, people, I guess you'd have to know, first of all, that what that means is 3 odd numbers in a row. Like 11, 13, 15. All in a row. Or 5, 7, 9. Or 21, 23, 25. Odd numbers that are consecutive, they all are in a row, and you got to figure out. And by the way, sum, I hope you remember that the word sum means like when you add. It's the answer when you add stuff. So it's like, what are the 3 consecutive odd numbers that when you add them up, you get 99? Now look, I'm not an idiot. I'm not so naive or whatever. That kind of thing. You can totally just guess and check. It wouldn't be that tough. It wouldn't be that tough at all to just randomly guess and check. I mean, like, heck, I'm going to say, like, how about like 31, 33, and 35? 31, 33. Oh my God, I think that's it. Anyway, forget I said that. The point is you could like just guess and check, right? You can just totally guess and check. But we're not going to do that. We're going to do an equation. So what's not known? What's not known is the numbers. Now, bear with me here. There are 3 unknowns. So it's like, okay, what do we call it? Like X, Y, and Z? Because there's 3 unknowns. So it's like we want 3 variables. So it's like, okay, so like when I do X plus Y plus Z, they're all supposed to add up to equal 99. How do I solve that? And here's the thing, you don't. So we need a better way than just having 3 different letters. So how about we kind of say, if the first number is X, now look, it's not like the next number is something totally random. It's the next higher. It's the next higher odd number. So wouldn't the next number be X plus what? If X is the first number, we could just say the next one is X plus 2. And then wouldn't the third number be like X plus 2 plus 2? So X plus 4. See that? Think about it. I think if you think about it enough times, you'll understand it if you don't understand it already. So instead of doing X, Y, and Z, I'm going to use X, X plus 2, and X plus 4 to represent our 3 unknown numbers. And now we can do this. Now, I'll be completely, I'll even do that, for crying out loud. But, this is what we have. We have like this. So I guess what you would technically look to do next is like distribute to clear the bubble. You know what I mean? So not really anything to do here. Look, what's going to happen? It's a plus sign, which is technically a plus 1. So really nothing happens. And then guess what? Now you have an equation that you can solve for X because there's only one letter, X. And we can get the X's like X plus X plus X. Those combine to be 3X. X plus X plus X is 3X. And then the 2 and the 4, those are also already like terms on the same side. You can just combine those together straight up and get 6. And then now we keep solving. We would subtract 6 from both sides and get 3X equals 93. And then the last step would be to divide both sides by 3 to get X equals, what's 93 divided by 3? Oh, that's right, 31. Now, what are they asking for? They're asking for the smallest of the three numbers. They could have asked for all three. In fact, that's usually what happens. But all they wanted was the smallest, which is x. Okay, so x was our smallest one. So x equals 31. Now, of course, the other two would be 31 and 33. Sorry, what did I just say? So let me say that again. The other two numbers would be 33 and 35. But, I think that's it. Sure.